All right, so thank you all so much for joining us this evening. My name is Gail Bonus. I work with the Gulf of Maine Research Institute, and I manage the Municipal Climate Action Program here at GMRI. And I'm lucky to, through that, get to work with coastal communities to support you all in better understanding the impacts that are to come with climate change. And we do that through capacity building, community engagement, and technical assistance programs and projects. And we also do that by collaborating with other organizations. And we're doing that this evening. So I'll have my colleague Leela introduce herself.
Hello, my name is Leela Pike. I am a civil engineer at GEI Consultants in Portland, Maine. And we have begun working on this project. We're thrilled about it. We look forward to continuing to work on this and look forward to any feedback you all have tonight.
Great. All right. And I know that we're also joined by several folks from West Newbury who've been really deeply involved in this project. So if you have if your videos on and you wouldn't mind kind of waving so that other folks can see you and see who you are. Christine's video's off. I see Arthur and Deborah raising their hands. And then we've got the town of West Newbury folks in the office as well have been really deeply involved in this project. And I'm not sure if Elisa's on the call, but she's just been a real champion of this work. And just for audio, I'd ask if you all could mute yourselves at home. That would be great.
So Gail, Rick Parker also joined here in the select board hearing room. So we have both Wendy Reed and Rick Parker.
Oh, excellent. Thanks so much.
There's something so the camera picks you up.
Sure. Okay. Does the camera see me now?
Yeah, there we go. All right, great. Thanks.
Great. Thanks, Rick. Yeah, just wanted to recognize the amazing kind of staff and community that you all have in doing this work. And Leela and I feel really lucky to get to collaborate with you all. So we'll get started with the presentation this evening. Let me share my screen. And then there you go. All right, so to let you know a little bit of what we're in for this evening, we've got roughly an hour or so that I'll run through some information. I would really love to not be talking at my screen for that length of time. And coming from an education background, I do like to ask a lot of questions. So we'll be pausing for me to ask questions of you all. And also I really invite questions from you to myself or to Leela as we go through the presentation this evening. So feel free to unmute and just hop right in, or to drop a question in the chat. Leela will be monitoring the chat this evening as well, so you can use that to ask questions. And we'll be first, Leela will chat a bit about what the project that we're working on with West Newbury, and then we'll dive into some global sea level rise science and then localize that science for your community. We'll look at some maps and projection data that Massachusetts has available to communities. And then we'll also consider, what does resilience look like in West Newbury and what are possible adaptation options in your town? And like I said, it'd be really great if this could be more of a discussion than a presentation. So please do feel free to hop in with questions or comments along the way. So I'm going to pass things over to Leela first to chat about the project.
All right, thank you. So I wanted to provide some background, the journey of this project. It has been a couple of years in the making, and that is thanks to the staff and volunteers of the town who worked tirelessly to apply for and get grant funding for a municipal vulnerability preparedness grant. That's a state funding program, provides funding and support for cities and towns to identify climate hazards, assess vulnerabilities, and develop action plans to improve resilience to climate change. There's a strong emphasis on community participation. So we've had a couple of events, or more than a couple of events so far throughout this project. Most recently was yesterday. We had some staff out there flying a drone and collecting measurements on culverts along River Road. And this project will take us through the end of June. So it's a condensed project. We're trying to get a lot done. And West Newbury received a $150,000 grant through this program to pursue this work. And then I'll talk a little bit more about the work in the next slide. So the goals of this project are to understand flood risk near River Road, flooding mainly due to sea level rise and storm surge. So as flooding moves upstream through the river. So how might that change over the years? Which areas flood currently during storm surge events, and what may flood in the future as seas continue rising? Along with that, we're looking at areas of bank instability along River Road. So that's why we had that drone out there yesterday to really get a seamless picture of the banks, places where it's difficult to see unless you're out on a boat, where we can identify where there is bank instability and then recommend some options for how to stabilize the banks. We will also be looking at the culverts along River Road. So what kind of conditions they're in? Are they operating as they intended, or are they crushed? Is there a lot of sediment buildup? Are they not as big as they should be because now we're seeing heavier precipitation events? So that's another aspect of this project. And then along with that, this full time we'll be looking at, we'll be including community engagement. And that's really Gail's expertise. So I'll hand it back over to Gail.
Great. Thanks so much, Leila. Yeah, we were happy to have the opportunity to come and visit West Newbury last month and spend some time along River Road and get to chat with you all during the town fair that was put on, where you've showcased a lot of really exciting projects and work and organizations that are supporting your town through various efforts. So it was lovely to meet some of you that evening. So my role tonight is to kind of like dive into talking about climate change and sea level rise. And I think in doing so, you would expect to see a lot of maps and graphs, but I really like to start all of my presentations with an image. And this is my image of choice. And I think if we think of the coast, we all would have our own kind of like image of choice, like the coast or the shoreline or the river shore in your town, thinking about places that we care about and how we use those places and how the environment relies upon that place and other species rely upon it, I think is a really important way to start conversations about climate change, because we're not just talking about graphs and numbers. We're talking about people in place, and we're talking about change within environments and within ecosystems. So this is a beach close by me. I'm in Cape Elizabeth, Maine. This is Crescent Beach, if you've ever been there, and it's a place I walk really frequently with my kids, as you can see in this photo. Something else that we get from looking at images is that images or thinking about the places we care about is that we can also see change. We can see evidence of climate change today. In this photo, you can see that the seaweed is washed all the way up into the dune grass. This isn't common for this beach. It typically does have a couple of feet of dry sand at high tide, but I was here following a high tide that also had a storm surge, which made this location exceed its flood stage causing salt water to go into the dune grass environment, which although is salt tolerant, it's not salt resistant. So if the water were to continue to do that over longer periods of time as sea level rise, that dune grass is going to die off from salt intrusion into its root systems. And we'll also see erosion along the shoreline there, the dune grass that's kind of protecting the shore from eroding in. So I invite you all to think about those places that matter to you, because I said it's a great place to start the conversation. And I think it's also a place to invite in the human component of climate planning, and that we're all going to be impacted by climate change in various ways, whether that's our own personal property and the economic impacts of that, or if it's a place or a place that we really care about and have like deep roots and history for, a place that we recreate, a place that we work in. And I just want to invite kind of the emotions behind that into tonight's conversation. And as I mentioned, Leela and I were really lucky to get some time on River Road last month. So we got to go to some of those places that I bet some of you were thinking about as I was sharing mine. And that is one that I think, Deborah, you had already mentioned, the trail that crosses Indian Brook. I'm assuming that's what this brook is. The down river section of River Road, that trail system through there, it was just beautiful. Even on this really misty day, it was such a beautiful location. And then the upper picture shows where the boat launch is. And we've heard a lot of people like to recreate through here and will either put their boats in to go fishing or paddling, and also hip waders on to go out and stand in the shallower waters and do some fishing. So through those stories, we know that this is a place that means a lot to a lot of people. And so we need to understand how these locations will be changing over time, and how can we kind of preserve those activities we care about, and or find other locations for us to do those if these spots are no longer accessible with higher seas, higher river levels. As you can also see in both of these photos, we were there during low tide. You can see exposed some rocks that you can see clearly have kind of water plant growth on them along the boat launch, and down along the marsh and the river you can see some mud flats here. So we were there during low tide, and the Merrimack River is a very tidal river. This is data from a tide gauge just slightly downriver from West Newbury, and you can see that the tidal variation in your town is 6 to 8 feet, depending upon if it's a high tide cycle or a low high tide cycle, and that varies based off of the full moon and kind of seasonality. But you can see the tidal levels were about 8 feet difference on this day, 7 or 8 feet. And kind of today, this is about a 6 foot difference. So you do have a very tidal river, and that can, that's an indication that your river frontage is coastally connected, and what happens along the coast as far as sea level rise and storm surge is also going to happen along your river frontage. Being a tidal river, we'll see this tide gauge or tide graph change over time. With sea level rise, everything will go up. And with storm surge, if it occurs during a high tide, you'll see peaks in that high tide on that day. When we're observing the water along these tidal places, it's influenced by various factors, the tide being the main driver. Waves, if there were to be some surge or wind, you may also get waves along your river frontage, also being a variable factor. Sea level rise has been a contributing factor, and it will only increase so into the future. And then storm surge is also a factor when we're looking at the water level of the day. And so I mentioned, sea level rise has been a small contributing factor thus far. This is data going back over 100 years where sea level has been collected globally using tide gauges or tide staff, some means of measurement along the coast until recent decades. And you can see this blue line is where satellite data started to come into play. So the reason why these aren't both in total alignment is because they're measuring data in different ways, but the ultimate end is that they're measuring water level data. And what we can see from both of them is that the trend is up. And if you compare just looking at the tide gauge data, you can see that the trend was rather steady until recent decades, and that rate of rise has really rapidly started to increase. And as we're talking about climate impacts, it's that rate of rise over time that's really important to be looking at, not the day to day. It's going to vary day to day, it's going to vary month to month and year to year, but it's that rate of rise over time. Climate cycles are roughly a 30-year cycle, but we're starting to think about climate over smaller decadal cycles as well. So thus far, the major contributors to sea level rise has been ocean warming. As ocean waters warm, water takes up more space and increases the volume of that ocean water. Another major contributor here in the Gulf of Maine has been a shift in ocean currents. You can see on this map, there's like this white line that kind of zips out through the Gulf of Mexico, up along the eastern seaboard and heads over towards the middle of the North Atlantic and eventually European countries. That's the Gulf Stream. What we're starting to see is a shift in the Gulf Stream and a change in its intensity or strength. And that is due to water warming and an influx of fresh, cold water from the North Atlantic into the Gulf Stream, which is shifting that. The Gulf Stream typically pulls water off of or out of the Gulf of Maine coastline. But as that's been slowing down, water's been increasingly it's not pulling it out as much, and we're starting to have more water here in the Gulf of Maine, and that's resulted in us experiencing sea level rise at a higher rate than the global average. This image kind of shows you that variation in rate of rise around the nation. The global ocean is not smooth and flat. It's actually rather lumpy bumpy, in part due to what I just talked about, ocean currents, in part due to in different areas of our continents, land is actually sinking and or rising at greater rates. And also gravitational pull is stronger in different areas. But here in the Gulf of Maine, you can see that our rate of rise is kind of in that yellow section, showing us that we are rising at a greater rate than the global average. All right, so I'm going to pause right there to see if there's any questions from you all, and feel free to unmute and just ask, and or you can drop it into the chat box. And I appreciate all the pets at home that are learning about climate science too. Thanks for bringing them along.
So Gail?
Yes.
Yeah, this is Rick Parker. How are you?
Good.
Good. Yeah, I guess it's kind of striking. I was under the impression that we were, unless I'm reading this wrong, the Gulf of Maine was among the highest rates of change worldwide. But it's interesting. There are a number of more reddish, the different tones of red, obviously. The Gulf of Mexico and off of the southeastern coast, and then some bright red in places. So that's just interesting. It wasn't what I had expected.
Yeah. Thanks for bringing that up, Rick. I'm guessing what you were remembering is around ocean warming. And when it comes to the rate of ocean warming, the Gulf of Maine is warming at a rate, and I think currently it's at a rate that's faster than 95% of the rest of the world's oceans. And that's actually
My confusion, yeah.
yeah, that's data that my colleagues at GMRI analyzed. And when they first did that, I think it was in 2012. At that point in time, it was 99.9% of the world's oceans. So like pretty much essentially the fastest warming ocean in the planet, but now I think it's 95. We're still up there. We're still getting an A. Not the A that you want, but yeah, that's likely the fact that you're recalling. When it comes to ocean warming, we're rising, or our water is warming at a rate that's greater than the majority of the world's oceans. For sea level rise, that's not the case. And the large reason why that's not the case is because land subsidence from extraction of oil and water and land sinking, as if you think about North America as being a teeter-totter, land is rebounding in the north as ice is melting, and therefore land is sinking in the south in response to that land rising. So that's exasperating along the southern eastern seaboard and down here in the Gulf of Mexico.
Thank you.
Yeah, great, thanks. Again, feel free to drop questions in the chat along the way, but I have a question for you all. Local knowledge is the best knowledge. So I would love to hear from you stories of flooding that you have experienced so far, and any kind of, especially if you've been a long time resident of West Newbury, if there's been any kind of change over time, stories or things that you have observed in your communities, then you can feel free to drop those into the chat and or unmute and share.
We've seen in recent years that the Artichoke River, which empties into the Merrimack River and is the border between West Newbury and Newburyport, at high tides, we can see the difference where that river is flowing upstream, above the level of a dam, that's closest to the Merrimack River. We can see in that way where the Artichoke River empties into the Merrimack, at times of high water, we can see the river flowing backwards in a significant way.
Oh, interesting. Thanks for sharing that, Arthur.
Hello, can you hear me?
We can.
Yes.
This is Jean Lambert. I'm a resident of River Road. I've lived here for about 38 years, and we have experienced flooding 3 or 4 times in that 38 years. Our house is on a bit of a rise, so it's never come up to the house, but it's come up the driveway about, maybe different levels at different times, but the worst was I think about 2/3 up. And my husband, who worked inland, was sitting in a meeting and said he had to get home before the tide came in, which perplexed a number of the people in the meeting, but that was the truth at that point.
Yeah, or you'd be waiting for the tide to recede.
Yeah, so
Well,
that's 4 major floods, I think, or 3 major floods in 38 years.
Right.
To clarify that, this is her husband. We've had several floods, what I would call, over the road on that. We had one very significant flood, which Jean was referring to, where the water came up almost up. We have a driveway that goes up the hill and then a flat area that goes in the garage. That was about a foot from the flat area. We also had it to the point where it was about 2 inches below the mailbox on the road, to give you an idea of how much it had been flooded in on that. Also, there was an area down River Road, which used to be referred to as the cornfield, which is now sort of a hayfield that's up towards the Rocks Village Bridge. and that was underwater fully.
Yeah, and just to wrap up this little tour, the intersection of Coffin Street and River Road is underwater quite a bit in heavy rains. In fact, there's usually a little lake there after a rainstorm.
But one of the interesting characteristics of the topology of River Road is there are certain spots that will flood over, and that's going to basically stop traffic flow for the whole road. So it's not just, here's a spot that will flood, everyone else is fine. Once those flood over, the whole road is basically now trapped.
Yeah, great. Thanks so much, Jean and John, for sharing that.
You're welcome.
Right before we started too, Deborah was sharing about the trail at the downriver side of the road. I wasn't sure if you wanted to chat about that a bit, Deborah. You had mentioned some efforts to rebuild that after flooding.
I'd be happy to. Of course, River Road originally was a road that continued all along there. I've been in town 48 years. And in my experience, it's really only been a trail, and it is subject to high tide flooding. Essex County Trail Association has over the years done some filling, some moving of big rocks so that even at the highest tide, people can hop from one rock to another and still walk the trail without getting wet feet. Those of us on horseback have the advantage of not having to walk through it ourselves, but bicyclists and walkers, I think, from one year to the next, are finding it harder and harder to walk that trail at high tides. I don't think it ever stays flooded through a whole tide cycle, but for periods of hours at each tide, it can be flooded. And in what's the town in St. Brunswick, in New Brunswick, that touts itself as having reversing falls rapids? The Indian River, St. John, under the Indian River Bridge there that you had in your photo, we have that same phenomenon where the tides go right up the Indian River another, I don't know, quarter mile or so, and then come gushing back out again. Thank you.
Great.
One other thing that ought to be mentioned is when there is a really heavy rain upriver, the flow coming down the river is significantly increased. Mm-hmm. When that then encounters an inbound high tide, that accentuates the amount of flooding.
Yep, 100%. Yeah. Great. Thank you all. Those are really great kind of illustrative stories of your lived experience in that place, and also kind of the use of the place, and talking about the ways that people will be impacted. So let's look into some of the data on how much sea levels may rise. This is data from a 2022 report that came out from the International Panel of Climate Change. The visualization is from NASA, and this is showing us different sea level rise scenarios based off of global carbon emissions. So the low scenario here is assuming, as a globe, we essentially stop our carbon emissions yesterday and start sequestering carbon using technology that's not readily accessible. So it's an unlikely scenario, but it's a part of the package. The intermediate scenarios assume that as a globe, we really start to cut our carbon emissions by the year 2040, and then start to sequester from there on out. An intermediate scenario would mean that we're staying more in line with what the goals were that were put out in the Paris Accord almost a decade ago at this point. The high scenario is assuming as a globe, we continue to emit carbon on the same trends we are today, which is an increasing trend. So we're just using carbon and greenhouse gases with the same patterns. So it's hopefully an unlikely scenario because a lot of communities are having these conversations. There's a lot of policy coming into place and we're developing new technologies. So again, unlikely, but it's part of the package. And then there's ranges within each of these. The lines show you kind of the middle of that range. On the side, we've got feet. So if you follow out like a 2-foot sea level rise, we'll likely reach that by the year 2060, if not sooner, depending upon the scenarios we have. Like an 8-foot sea level rise, and an 8-foot rise would mean that your highest of high tides today becomes your new low tide. An 8-foot rise, if you follow that out, would be like an extreme in 2100 and becomes much more likely towards 2150, which feels like a really far out planning cycle. But if you think about the time scale it takes to plan infrastructure that you want to have in place for a very long period of time, so thinking about emergency evacuation routes, thinking about emergency services or schools, it takes an awful lot of time to permit and plan for that infrastructure. By the time construction is done, we're looking out like a decade from now. And you want that infrastructure to stay in place. So planning on a 2100 year scale for things like that is not uncommon. And then thinking out to like 2150 may be something, depending upon the level of risk that is acceptable at that site. So again, coming down to like things like emergency infrastructure, such as emergency evacuation routes, emergency services, emergency shelters. Considering the high scenario is where planning would need to happen. And for other sites, you can determine what your level of risk is, but staying in this intermediate zone is likely a safe place to be in. And then where this uncertainty kind of comes over time, you can see like how the low to the high really start to deviate is because as I mentioned prior, the climate cycle is roughly a 30-year cycle. So the impacts of climate change that we're witnessing and experiencing today are because of greenhouse gas emissions from 30 years ago. So we know fairly well how our planet is going to react for the next 30 years. Beyond that is where we don't know where our kind of global policies will take us, and how our ice sheets in particular are going to react to those greenhouse gas and warming, that greenhouse gas emissions and warming that may take place. So this is rather illustrative of that kind of uncertainty in ice melt coming from primarily Greenland and Antarctica. So here's our scenarios again. The low scenario, oops, back to this one. The low scenario through to the high scenario. The blue is showing us the amount of melt that's contributed due to ocean warming. So we've gotten most of the ocean warming out, and the kind of volume of the ocean expanding due to ocean warming is essentially occurred already. Same as vertical land motion for Massachusetts. That's pretty much a steady, that's not going to change. Where the change is really going to happen is in these lighter pink bands, Greenland, and really in particularly Antarctica here, you can really see the difference. When you get to 2100, that's where you can see a really vast difference, because we don't really know what's going to happen to that Antarctic ice sheet. The science to date here is showing us how ice melt in Antarctica may react under different warming scenarios. And underneath a warming scenario of 1.5 to 2 degrees as a globe, the melt of Antarctica is kind of steady. But if we get over that 3 degrees of warming as a globe, that's where that ice sheet is going to become really unstable. So although as we're talking about sea level rise, we're mostly talking about adaptation options or our actions to kind of live in this new reality with higher seas. We also at the same time need to be talking about mitigation actions or actions to reduce our greenhouse gas emissions. So that way we as a globe can avoid this 3 degrees Celsius of warming. And because it's a curious question, how much ice is there between Greenland and Antarctica? So to date, Greenland has contributed 1.6 inches of sea level rise to kind of the 8 inches of global rise that we have measured. Antarctica just 0.2 inches. So most of the melting has been happening in the northern hemisphere, but Greenland only has a potential of 23 feet total, whereas Antarctica has a potential of 187 feet total. So there's a lot of land ice locked up in Antarctica. And that's where a lot of the science is focused now, and understanding the stability or instability of that ice sheet and how it may react under these different warming scenarios. And if you're into some doom and gloom and are curious, a Google of what will the world look like if all the ice melt will get you a really interesting map. Know that that's not going to happen. All the ice will not melt. And it definitely will not in our lifetime. It would take hundreds of years, even under those warming scenarios, to see that happen. So I'll pause there if there's any questions before we look at some maps about what sea level rise looks like in West Newbury. Okay. These pauses are a little bit for me too, so I can take a break in chatting. All right, so we're going to look at some maps. These come from the Massachusetts coastal viewers, and this one is looking at sea level rise specifically. So I'll give you kind of an orientation if you want to look over on the far right side, assuming it's your right side, it's mine, at the legend here. It's showing us mean high water, which is your average high tide every day. And then what mean high water with 1 foot of sea level rise all the way through to what 6 feet of sea level rise may look like. And the different colors correspond to where that water would go. So today you would expect to see everywhere that's blue, be blue with water, or to have water on top of it. With a 1 foot rise, that would be like a storm today, which we've experienced, as you guys already shared, quite a few of those in the past couple decades. 1 to 2 feet of rise may be representative of where we've seen storm surge push water in kind of our experienced kind of high tides. Up to 6 feet of rise, again, that's like looking more out closer to 2100 in one of those intermediate scenarios for planning. If we were to look closely at River Road here, you can see where River Road ends and the trail system begins. And it's going to become pretty much a salt marsh area where water is freely moving in and out during all of those high tide events. And with a 6 feet of rise, the blue that you're seeing might be where the water stays most of the time. That may be your new low tide with close to a 6 foot rise. Looking along River Road, you guys had mentioned the intersection at Coffin Street is an area that floods frequently. It's kind of got the yellows and oranges. Yellows, that 6 foot rise, but kind of the reds and oranges, you can see kind of a lower end of sea level rise. We'll start to see some impacts there. along this part of River Road. You can see another significant amount of flooding at the red. That's more near term. And then down here, I think this is where there's a bridge, correct? Okay. And kind of a low-lying field. Is
That's the
that
cornfields or the
Alright.
hayfield.
That's the cornfield that I was referring to. The
great?
bridge is
Thanks,
a little bit
John.
further up.
Oh, right. Yeah, thanks, John. I was thinking this was kind of that open field, that cornfield, so low lying. And this is kind of the orange, like the light orange and yellow. So this is the higher amount of rise scenario. So again, that would bring salt water into a place that perhaps is sounds like used for farming. Salt water in cornfields is not going to mix. So it's not going to be a profitable place for agriculture in future years, but perhaps will be a salt marsh habitat. Right. Any questions or observations that you want to share about this map before we look at some others?
Just the heavy black line is the power lines, right?
Correct. Yeah.
Okay.
Yeah,
John?
Gail?
Go ahead, Rick.
Yeah, you made reference to saltwater. So, currently, based on the best information I've been able to find at least, the Merrimack River is not salt past what's referred to as the back river in Amesbury as a reference point, which is, I don't know, probably 3 or 4 miles further downstream. I talked with USGS about a year ago, or traded emails with USGS about a year ago, and didn't really follow it up further because they didn't have good data, and it didn't look like it was something that they were going to model, and certainly not in the near term. So I just note that because
Yeah.
the salt water will come farther upstream probably as sea level rise comes up, but it's not clear, how fast that's going to happen or how far that's going to happen based on the degree of sea level rise.
Yeah, good point, Rick, and thank you for mentioning that. And I should have used the term brackish, which is somewhere between fresh and ocean salty, which I think is 35 parts per million of salt. So during high tide events, this would be really interesting data actually to collect. Maybe an interesting project for high school students because measuring salinity is not a tricky thing to do, and you can get some pretty inexpensive tools to do so. But how does the salinity of the river change during different tidal cycles? Because you're right, there is fresh water coming downriver, but during high tide, salt water is pushing in. So how much of this water is fresh water being pushed back in by the salty ocean water versus salty ocean water coming in over the fresh water? And I think that would just be a really interesting piece of data to collect, in particular as we'll talk about later, nature-based solutions or using plantings to prevent or erosion or to create additional stabilization along the coastline is a really great strategy for many ways. And we'll chat about that in a minute. But knowing the salinity of the water will really help determine the types of plantings that you would need to put in place. So I think that's a really interesting question to explore.
There's one other piece which may or may not be significant. When you have a significant, well, at this point, it's not even significant. When you have rainfall, we are getting sewage overflows coming down the river.
Yep.
If we're in a flooding scenario, that is now coming onto the land.
Yeah, really great point, John. And Yeah, Leela and I noted the signage that's heading into the trail system, like do not swim if there was heavy rain within 48 hours. And that was brought up again that evening. So understanding that this water coming onto land may have a varying degree, was likely brackish. And also if it's during a rain event, which would just exacerbate the amount of water, it could also include other contaminants. So understanding how we can use nature-based solutions to perhaps like that are salt tolerant and could filter those contaminants before it goes back out into the river could be a really interesting kind of place to explore and something that to understand better. On that note, I just want to so looking at this map, this is showing us just sea level rise on a sunny day with no precipitation, no snow melt, no added flow to the river, just on your mean high tide. We're noting that the high tide does vary and does get higher than the mean, but this is just your average sunny day in a week with no rain events. But we live in New England and weather happens. And so, that was a transition to the next map. I'll transition to the next slide first. All right. So when I was doing research for this talk, I saw that Massachusetts just recently released a new comprehensive plan for climate resiliency. It just came out on October 20th. The link for that is here. And within it, it states, if global emissions are not significantly reduced, so we're continuing to emit greenhouse gases as a globe on our existing trend, that Massachusetts will experience sea level rise of up to 2.5 feet by 2050 and up to 4.3 feet by 2070 compared to the mean high water level of 2008. So I just wanted to share that, and I'll pop back to this map. So 2 feet, well, there's not a measure for 2.5, but is kind of between these lighter shade, or where red starts to turn into orange. So that's where you could expect your average high tide to be in 2050. And you can definitely see locations where it's touching the road and or this is kind of down by the trail system starting to come over it. And I also don't want to forget about your water access point over here too in Ferry Park. The condition of it may impact the ability for folks to be able to put a boat in there as well. And then upwards of, I think it was 4.3 feet. So the lighter orange by 2070 is something that you would expect to see. And again, that's where you would start to see this area fill in 2070, as well as the cornfield over here. And again, this is just sea level rise on a sunny day. All right, keep bumping around where I've got all of my video of you guys. So sorry if I'm stumbling between slides here. All right, so that's what Massachusetts is planning for. Leela and I will be digging into these recommendations a little bit more and see how they best apply to the work that we're doing with you through this project. So this is another series of maps that the Massachusetts Coastal Program has released. And these are looking at the high predictions of sea level rise for the years 2030, 2050, and 2070, and storm events, coastal storm events that could happen during that time frame. So I'm going to run you again through the legend, which is on the right of my screen. So the gray area is where you would see water during a kind of typical like day with like a small small storm. So a storm that has 100% chance of happening this year. A storm that we would definitely need to be planning for. The purple is showing us a 10-year storm. So a storm that has a chance of happening, like a 10% chance of happening within any given year. I know in Portland, Maine, that storm would have like roughly 1.5 feet of surge associated with it. And then the light shade of green is showing us a storm that would have a 100, or it would have, yeah, it would happen once in 100 years. So a 1% chance of happening a year would likely happen once in 100 years. The way that we define storms today is also going to need to change as we're experiencing climate impacts, because this is not taking into account the increase in extreme precipitation events that we're also going to coincide with sea level rise and these storms. So the frequency of like today's 100-year storm is likely going to be different in 10 years and 20 years. So again, these are based off of the likelihood of that storm happening this year. Massachusetts goes all the way up to a 1 in 1,000 year storm. So this pink is like a super unlikely storm. I don't think it's one that has ever been experienced. That I know of. I know the blizzard of 78 is one that folks have strong memories from, and that was a 100-year storm. So I don't think I have not heard a story of a 1,000-year storm. So it's part of the data package here, but it's really unlikely. So let's look at where we see water come during these events. And I want you to, as I go through kind of 2030, 2050, 2070, just to kind of look at the certain shapes of the colors currently. And I'm just going to run through them a little bit quickly, and I'll come back to this map and note what I observed when I was looking at this. So this is 2030, 2050, 2070. For the most part, these shapes remain the same. So your low-lying areas are surrounded by steep embankments, except for this one location over here, adjoining kind of the cornfields to Ferry Park. The rest kind of along River Road, and this marsh here along Indian Brook or Indian River those areas are rather contained. So we'll come back to 2030. You can definitely see that with like 100-year storms, we're seeing the road breached over in several areas. I think this is where a trail system starts. There's like a parking area on the inland side of the road. Intersection of Coffin Street, as well as a few other locations along here where we're seeing flooding during those 100-year storms. The cornfield is essentially fully flooded. You're starting to see, we can see an inlet of water that will be more steady staying there. But there's clearly there is a steep embankment here at Ferry Park, so it doesn't experience flooding until you get to a larger storm level or more additional sea level rise, actually. So 2050, you can see the coastline is really starting to change throughout the kind of average day or average storm, where areas of River Road are currently in that kind of gray, kind of the areas where the new water levels will be more consistently throughout the year. There's a couple of spots where that occurs. And then same for 2070, where the cornfield currently is, will become a place that essentially will have water almost all of the time. And same for here around Indian Brook. And an awful lot of flooding at the intersection of Coffin Street, again, that gray, and it comes into that intersection, as well as almost, and I'm not, Leela, this is something Leela will be able to get into, as to how many feet of road is impacted underneath these scenarios. That'll be, I think, part of the report. Feel free to correct me if I'm wrong on that one, Leela. But even on these more nearer term scenarios, something that you had mentioned, John, also like jumps out to in the near term. So in, oh gosh, 6 years, being 2030, with a small storm, you'll experience flooding that will cut off residents of River Road from both access points through the town towards Main Street, as well as Coffin Road, and making kind of access to emergency services, let alone everything else, really inaccessible for these residents, regardless of if their home is on the inland side and high and dry, or on the river side and they're experiencing some flooding. So in the near term, that is an issue. All right, so I will pause there, and happy to answer questions or flip-flop between these three maps.
I wanted to ask, on these scenarios where you have the percentages, what is the sea rise, for instance, in a 1% year, 1% storm?
Great question, Jean. For each of these storms, it's assuming the high rate of sea level rise for the years. So I think it's 1.2 for 2030, 2.5 for 2050, and 4.3 for 2070 feet of rise.
Can you just
Yep.
run by those again quickly?
Sure.
Or not so quickly?
Yeah. And Leela, hop in if I had those incorrect. We were just chatting about them prior to the call. 1.2 by 2030. And we're already a bit towards that, because these are based off of the 2008 level. So it's 1.2 feet higher than 2008. 2.5 by 2050 and 4.3 for 2070. And those are in alignment with the recommendations that were part of the climate preparedness report that the state just released.
Thank you.
So, Gail, just to clarify, I think, and this sort of goes on top of what John Lambert said earlier, that the numbers shown here reflect flooding from sea level rise, but don't account for downriver flooding. Flooding from coming from down the Merrimack River. So if there's concurrent major precipitation event to the north, with significant flooding from sea level rise, it'll be exacerbated.
Yeah, correct. These are coastal storms, and it's not to say there's not precipitation that's a part of a coastal storm, but it's not a major piece of the modeling. So it's not taking into account, like you can see, even just the tributary river here. And I feel like we saw one here as well that's not on the map. So it's not taking into account how those rivers may already be overtopping their banks from inland precipitation events or snow melt events. I've been doing this work for almost a decade, and in Maine we have a lot of tidal rivers as well, and there's data and predictions on river flow under different scenarios, and then there's data and predictions on coastal impacts in those scenarios. But this space where freshwater meets salt and how to view those together, I think, is a rather new space that where we need to to better understand how those two kind of predictive models work together and what would the resulting impacts be for a community, so that way we can visualize and plan for it. There's not widespread models for how that looks or ways to get that data easily accessible for towns currently. So that's another area for needed research.
Then as long as you're having so much fun now, why don't we throw one more minor variable in there?
Let's do it.
Upstream, we have dams.
Mm.
And on those dams, when there's enough flow coming down, the towns may start to release water to abate the pressure on the dams. That's assuming there is no structural issue with the dams.
Mm-hmm.
If there is a structural issue, that's a whole nother scenario.
Yep. Yep. Yeah, particularly as municipalities that border this river on both sides, and municipalities that are throughout 3 different states on this watershed, this river in particular, having a coordinated effort is really going to be important. And I was glad to see, and I cannot remember the name or their acronym, but there is a really active organization that is thinking about the Merrimack Valley watershed. They were at the town fair that Leela and I were at last month as well. And I think that organization is one that you can lean into to support that coordination between towns. I think it's going to be really essential for planning.
I'll
I think
just
that's the
hop in
Merrimack
for
Valley Planning Commission.
Merrimack Valley Planning Commission. Great, thanks. Leela, I heard you chime in there too.
Yeah, I just wanted to hop in to add a little bit more about the river flooding and what climate scientists are saying at the various conferences that we go to. And the main consensus is that it has not felt like it, being an engineer and a scientist in this field of work. It has not felt like we have a great grasp on sea level rise, because the trends are changing and states haven't decided on which levels to use. That's all been very recent, that states and municipalities have really started saying, let's plan for this, let's plan for this. But that the sea level rise component is much more understood than how river flows will change into the future with climate change, because there's competing factors. One of the main things is competing factors. So there will likely be more intense precipitation events. There will also be higher temperatures, and higher temperatures alone will actually decrease river flows, because you'll have more evaporation, less water actually in the river. Higher precipitation events alone would increase river flows. But the combination and how that plays out in different regions, it's very dependent on what the river flows are based on. Is that river flowing from a mountain? Is it getting its flows from snow melt in the spring primarily? Is it in a hotter area in the world? So the consensus has been that it is river specific, and it's been really hard to pinpoint how flows will change. And there's a difference between how the average flow of a river will change, like your daily flow that you'll see, and how a storm event flow would occur at a heavy precipitation event, for example. And as you were mentioning, John, the dams upstream, so how those are regulated, that's all dependent on the dam owner. Maybe 50 years from now, a dam would be removed, and so that will completely change the river flow. So everything is frustratingly in flux, but we do the best we can, and yeah.
So I was pleased to read that Massachusetts is recommending kind of planning more towards those high levels of sea level rise, in part because it does account for storms or river flow as well. And also Maine adopted levels to plan for 2 summers ago, and my perception in working with communities around that is that it's a real gift. The amount of resources that we have to do this work is limited, so the amount of time spent, what level do we plan for in this property versus this property, and that kind of infrastructure, this type of infrastructure could be so immense that you use up all of your resources. So now we have these recommendations as a state. What do we plan for? And we can start envisioning what does that look like and what does that mean for our community, as opposed to running through all of these scenarios. And this map is reflective of those kind of committed numbers, and will be a great resource for you. So great. Kitty, I saw you unmuted. Did you have a question? Okay. All right, we're gonna move a little bit, well, wait, not quite yet. A little bit more of the doom and gloom. I wanted to, let me get through 2070 there, to share with you just like a snapshot of kind of the impacts that a coastal storm can have along a tidal river. So this graph is your tide gauge data, again, just a little slightly downriver from you, from the December 23rd storm of last year. So we're almost up to the anniversary of that. And you can see that the water level is almost 2 feet higher than, or it's definitely 2 feet higher than the next highest high tide, and almost 2 feet than the one that followed it. So there was like roughly 2 feet of surge that likely happened during that storm event. And the resulting impacts of that, the town shared some imagery with Leela and I, and you can see that at this point in River Road, the whole kind of river shoreline was flooded over, bringing the water up and onto the side of the road. And you can see the high water mark where the water was even higher than it was when this photo was taken. So
the photographer is standing in our driveway.
Oh, this is your driveway. All right, that would have been quite the day, John and Jean. Yeah. All right. So let's switch the conversation up a little bit and let's chat about resilience, because that's really kind of at the end of the day why we're all here. We need to understand what those climate projections are, where our vulnerabilities are, what those mean for our community. But then we need to start to talk about, well, what are we going to do? And I think that this conversation is one that can bring in a lot of hope. It can bring in a lot of creativity. It can also bring opportunity to enhance our communities beyond where they are now. We need to invest in change to build resilience. And that change can be building our communities forward into something that we envision together, as opposed to just solving and fixing a problem. So I think it's a great place to really engage the whole community in the conversation and to build in some hope into a lot of the stress that can come from it, looking at and also witnessing and experiencing these climate impacts, as a lot of you are being on River Road, which is kind of the forefront of coastal climate change in your community. So I'm going to run through a couple of different kind of buckets of adaptation, or ways to frame up how are some ways that we can think about resilience. One is that we just first need to observe and acknowledge what is happening within our towns. We're witnessing and experiencing climate change impacts today, and we can leverage and use these experiences, just as you already have this evening, to tell that story and talk to our neighbors and talk to our friends about climate impacts and really start to shift the conversation to get more folks involved. And we can talk about climate without using the word climate. Just as you all shared some of the flood impacts that you've witnessed and experienced on your own properties, that's a great place to get the conversation rolling. And you're talking about flooding at that point in time. You're not necessarily talking about greenhouse gases and human caused emissions around climate change. But we're talking about our lived experience today, and it's a great entry point into climate work. We have a project with West Newbury as part of our community engagement strategy with this project that will be rolling out early next year. This is a snapshot of a draft map that we're in the midst of creating. You can see that there's still some work to do on this snapshot. This is a community science project that the Gulf of Maine Research Institute hosts. West Newbury will be amongst, I think, roughly 20 other communities participating in this project. By working with the town committee, we identified 5 locations along River Road to collect data about flooding impacts. You can see those noted here by the blue place marks. There will also be some more information about them this is just a screenshot, but if you click on the place mark, you'll get some information about these sites as well. These are sites that are publicly accessible, being the boat launch and the trail system, and also along kind of the roadway here, kind of noting pinch points. And you can probably think back to the maps we looked at. These are areas that are flooding in the near future. So the Community Science Project invites folks to go out to the sites during high water or storm events, to take photos, to answer questions about the weather that you're witnessing that day, as well as to answer questions about the type of impact you're experiencing and like your level of concern or what this is making you feel and your ideas for adaptation. And this data will be fed through to the National Weather Service to support them in better creating predictions for flooding within towns. We can also share it with emergency management, so that way if they needed to close off a road, they'll have a better understanding of what water level and weather conditions would result in needing a flood closure. And we'll share this data, of course, will be accessible to the town to support their decision making. And it also creates a really great communications tool and engagement tool for everybody in West Newbury. It's a real intergenerational effort where all ages can get involved. Another strategy is thinking about protecting ourselves from water or keeping the water out. And this is a traditional kind of engineering solution. And it's one that's more kind of responsive as opposed to being preparatory. You're kind of an event happened and you're needing to respond following the event. These are often more costly, and their success is finite in time. Any solution that's intended to keep the water out will eventually fail as sea levels rise and perhaps storm intensity increases. But until we can come up with a longer term solution, this could be a good near term solution. We're also seeing areas where we're learning how to accommodate to continue having the infrastructure and access that we need, but we're accommodating water. We're allowing water to still come and go. We're just making more space for it. So often this looked like raising roads, creating larger culverts, turning causeways into bridges. For home infrastructure, that could be waterproofing your basement, moving your utilities up into the ceiling or the first floor out of the basement or flood zone of your home. and or raising homes, particularly in a more kind of low-lying beach environment. You've likely seen that happen. Nature-based solutions we mentioned before. These are a really amazing and beneficial strategy. Nature was our first defense against flooding, and it can become our first defense again. In many places, we have taken away nature, and or nature has kind of eroded over time, which is a natural occurrence. That erosion may be speeding up due to increased water flow kind of downriver, as well as storms and sea level rise coming upriver. But by creating ways to kind of capture sediment and allow these natural habitats to grow back, and or raise them by introducing more sediment or new sediment to grow taller, can create a great buffer zone, which can lessen the impacts of water before it reaches infrastructure. And as we mentioned earlier, it could also be a filter for potential contaminants that could enter the water. And so this is showing us essentially I think 100% green solution, because these kind of long, narrow things are fallen trees that were collected in the area. I think these are oyster shells up in this one to catch sediment. But nature-based solutions can range from 100% green to almost gray, which was that Protect solution I showed you earlier. There's a whole range of those. And there's also a fair amount of funding for nature-based solutions currently. And the ultimate actual nature-based solution and another strategy is to move or to retreat, or to take the infrastructure that's currently in that vulnerable zone and to relocate it. Unfortunately, the first kind of impacts of this tend to be the most vulnerable communities, and particular Indigenous communities in Alaska and Louisiana currently, where they're relocating entire towns, and unfortunately they have like a cultural history of needing to relocate. So conversations around kind of managed retreat or climate migration can be really sensitive when people and place and culture and their sense of place are involved. But there are other examples of kind of retreat or moving that are more infrastructure based. In my hometown, actually, we've just received a grant to remove a roadway that goes across a low-lying road that goes across a marsh system, and it floods during astronomical high tides. And the cost benefit of putting in a raised causeway or a bridge, it just doesn't, it isn't beneficial considering the importance of that road and the use of that road. So the town has decided to remove that road and return that area back to marsh. So that's also another example of relocation, and again is really the ultimate nature-based solution. But all of these solutions kind of really need to come from a community-centered place. What is it about your community that you value, that you appreciate? And these could be the ways that we interact with each other. They could be physical resources, but having these conversations as a community about what you value, what you envision for your future is a really important place to start as you're considering what are these different adaptation options for our community, and how are we going to get to this future that we envision together. So some upcoming engagement opportunities that we have through this project. One where we've recorded this evening and we'll share it with the town to put on their website. So feel free to share it with your neighbors and friends. As I mentioned, this winter we'll be launching the community science project, as there's some predicted high tides and also likely some coastal storms that we'll run through. So we can kind of capture what are the water level and weather conditions today that are contributing to flooding, or see where it's kind of almost going to flood, which areas are most vulnerable. Leela and I will be taking this data and developing some interactive maps, so that way folks can view the report and zoom in and around to places that they're interested in and view it under different scenarios. And again, this will be done in a way that's accessible to the public and can create a narrative of these impacts in your town. And then closer to the end of this project, which is in June of next year, we'll be doing some site visits and we'll host another community meeting in which we'll launch the final report. And just one more point before we end things out tonight is another way to think about climate planning or climate change is instead of the projections of what areas are going to fail or how is our place going to kind of change or flood or be too hot to live in or like an intense or ticks become too much of an issue. Like another way to think about it is when we become a more resilient community, these are the types of qualities that our community can have. We can have a healthy ecosystem. We can respond to some equity and justice issues. We could be a climate literate society. Our infrastructure will be more resilient to storms and weather events. And by doing this process, we may have a renewed sense of place and pride in place within our communities. So it's a different framework and perhaps a more hopeful framework to consider looking into this is thinking about kind of this possibility we have for our future first and the opportunities that come with that as we respond to climate impacts. All right, so that's all I have for you this evening. And again, I would welcome questions. Feel free to unmute and ask or drop some in the chat.
Are the maps that you shared accessible to the public?
Yes, they are. When I send this recording off to the town, I'll include the links in that email and that can go right onto the website. So all of the resources I referenced, you can have those links to click to right there.
Thank you very much.
Gene, I took screenshots of them all.
Okay.
I'd like to thank you very much. I think that was a great presentation.
Thanks so
Eye-opening,
much,
a
John.
bit scary, but good.
Yeah.
Can you just take it off me for a second? So just a last comment, from the standpoint of the Climate Change Resiliency Committee, where, the citizen science part of this will be really helpful, really important. And I know a number of the people who are on this call right now live on River Road. And when there is an event, you can get real-time shots of what's going on, and that will be really helpful in understanding the real conditions.
Yep, absolutely. And although we've only indicated like 5 locations to collect data, the website allows you to upload data from anywhere. So if you're not at one of those locations and you want to upload and share data, there is a way to fill out the form and just kind of note where you're at on a map and just state that you're not at one of those 5 sites. Our intent behind those 5 sites was to focus data collection for folks that may not be familiar with River Road. But yeah, I invite you to upload data from all along there, particularly if you want to from your driveway.
Yeah, Leela, you might be able to weigh in on this. So yesterday when I was walking along the shoreline with Allie, so she could see current conditions, we walked all the way up along the shoreline at low tide. She had a listing of house numbers. So if you do take pictures and they're not at any of the 5 locations, if you can document by house number, Leela, would that be the best way to locate them?
Yeah, we could definitely get a sense, we have, I don't know if my video is doing this. We have a parcel map that shows the house number location. So if we have that information, we could have a general sense of where that picture was taken.
Great, thanks.
Great.
I mean, if you can basically indicate more specifically what it is you're looking for information-wise, the what, the where, and the when, I think we can certainly work to support getting it from our area.
Great, fantastic, John. We'll be sharing out the what, where, and when around the Community Science Challenge. And then Leela, I noticed there's a question in the chat that you will be able to answer around storm water drainage and culvert kind of conditions and how that's part of the study.
Yep. Yeah, so we are looking at, is my video flashing for everybody or just me? It is. Okay, I'm going to turn my video off so that I'm not distracting. Okay, so we are looking at the stormwater drainage and culvert crossings along River Road. So yesterday we had a couple people out there taking pictures, documenting the conditions. We made it through most of the culverts, but we will be headed out there again for another day of collection. So we're looking at the size of them, the elevation of the invert, which is the bottom part of that. If you imagine a circle when you're looking in, it's that bottom elevation. And if they are blocked by rocks or debris. So we're doing a comprehensive assessment of those and the conditions of them. And we will also be we'll be creating a model of basically just of West Newbury, but looking at rainstorm events. So a local rainfall runoff study, using that information we collected on the culverts and the drainage system to see if the culverts are sized appropriately or if there are some clear areas where we may want some larger culverts to alleviate some of that flooding that we're experiencing from rain in West Newbury.
Be aware, there's one spot on River Road, not far from, it's on our property, where the culvert is a two-way street or stream. As the tide comes in, the water goes through the culvert and starts to flood the area. On a really high tide, the whole area is flooded over. And then, of course, then it turns and drains out again.
Mm-hmm. Yeah, are you down near the intersection of Coffin Street? I know that culvert experience.
This is between 215 and 211 River Road.
Okay. Yeah, we are anticipating seeing that happen with some of these culverts that are, the inverts are lower in elevation.
Yep.
Great. Well, we made it to 7:30 on the nose. Thank you all so much for your participation, your listening, your engagement tonight. It's not an easy conversation to have, but it's a really important one. And so just invite you to find ways to talk again with like your friends, your neighbors, your family about the climate impacts that you're witnessing and your concerns, and to listen to them about theirs, and to come at it from that kind of change in place first, as opposed to perhaps kind of the traditional greenhouse gas changes around or impacts on our climate, because we're talking about change that we're going to be witnessing and experiencing and need to adapt to. So kind of bringing that personal element in, I think, is really useful. And that's a great next step for you all, is having those conversations. And Leela and I look forward to continuing to engage with your community. You'll hear a bunch from us over the next 7 months, especially as we launch the community science project early next year. So again, thank you all so much. And if you have any questions, there's a nifty project website on the town's webpage or that you can get to, and there's an email there. Feel free to ask your questions there and they'll pass them along to Leela and I. And I hope you all have a great evening.
Thank you.
Thanks, Gail.
Thank you very
Thank you.
much.
Thanks,
Leila.
thank you. Have a good night.
Bye all.